Awesome. Welcome, everyone. If you can see me and you can hear me fine, and you could please put, can you please put in the chat? Yes. Awesome. Awesome. Perfect. If at any given point in time you stop hearing me or you stop seeing my screen, which I'm about to share, please let me know. And yeah, let's get started. All right. So welcome everyone to day 2 of SciPy Japan 2020. Very excited to have you here and joining me for this tutorial. So the first thing we're going to do is to get you all set up with the repository where all of the notebooks and everything you need for today lives at. So I'm going to paste the link to the tutorial instructions in the chat. Please follow this section that says getting started, section 5. So I am going to paste the link in the chat. Okay, so there's the link in the chat. You can also see it at the very top. I'm going to zoom in my screen here. When you get to this section, make sure you already have Anaconda installed, and then make sure you either download the repository by clicking on the code download zip file in the second option, or you can do it all through the command line with the first step, second step, third step. So let me know. And Warner, I believe, oops, yep, that's right. The chat is set up to write to the panelists. Let's do everyone. All panelists and attendees. Thank you. There you go. And Warner, correct me if I'm wrong, right now we're going to cover getting everything set up, and then the actual tutorial is going to start in about 30 minutes. Is that correct?
I believe we can go ahead and start.
Okay, perfect. So no, that's great. Go ahead, sorry.
You have 3.5 hours. It's all yours. So
yeah, okay, yeah. Perfect. All right, so what we're going to do is when you are set up, please let me know if you don't see the link in the chat. And when you finish setting things up, please say I'm done in the chat so that I know that you are all set up and ready to go. I'm going to put the link again just in case. And while we do that, how about we start talking about why this tutorial? So this tutorial, Ask Me Anything About Data Analysis at Scale, is really covering what we really want to cover today is the nitty-gritty details of what happens before you actually get to the analysis part, and how does that happen when the data we have is on a massive scale. So this came, by the way, my name is Ramon, and I work in as a data analytics instructor, data science instructor in Sydney, and I also work as a research associate at NCI, a business school with campuses in Singapore, France, and Abu Dhabi. So in one of my projects for the last 6 months, we were working with over a terabyte of data that involves job descriptions of all the jobs that have been available in the US. So that is a lot of jobs, close to 500 million job descriptions that have been posted in the US in the last 13 years. And it came in a somewhat tabular format. what happened was is that of course you cannot go and analyze all of that data. Doesn't matter how much compute you buy. You don't want to read into you can, but you don't want to read into memory of your computer about a terabyte of data. So the Python scientific community has come up with amazing tools, and one of those is Dask. I noticed that there are extremely awesome tutorials online to work with Dask, and I would highly recommend that you follow those first before you follow mine. But anyways, we are here today. What those tutorials didn't really go into a lot of depth was into the cleaning side of things. When you have a lot of data that is not readily accessible, or in a nice format that you can just go in and start deriving some insights from. So this was a little bit frustrating, and getting around it with messy CSV files was a headache to a certain extent. So I felt like, okay, let's create this tutorial and then let's show people how to use Dask data frames to actually get the data clean. Now, a big disclaimer: when you have massive amounts of data, usually getting to the cleaning part, you can get a lot of the cleaning done by just sampling some of the data that you have. So for example, if you get started if you have 500 gigs of data, and you get started with maybe 1 to 2 gigabytes of randomly selected rows from your 500 gigs of data, you can probably get a lot of good code out of it, and you may not ever need to read into memory the entire data set. You can do a lot of analysis and scale that, or infer what might happen once you go into the full data set. But what happens with the small amount of cases where you need to read in a large portion of the data to detect the edge cases, or the things that are not easily available or visible in your data, things that might mess up your analysis along the way and might make you come right back to the cleaning stage. So to do that at scale, we can take advantage of one of the tools in Python called Dask, and that's one of the things that we're going to explore today. We're going to learn a couple of the APIs that Dask has to offer, and we're going to do so while cleaning a lot of messy data. So let me know while you're getting set up if you are all done so that we can get started. I'm going to wait maybe about 5-10 more minutes until everyone's set up. So let me know in the chat once you're done, and then we'll get started. A couple of things. We'll try to follow this setup. It is right now 9:11 a.m. Tokyo, Japan time. So I'm going to walk over a couple of things that I want you to keep in mind. There's the links to the presentation should be available to everyone, but I'm also going to put it in the chat. If you want to follow along. And then we'll get started coding. There's going to be a short break at about 9:35. Then we're going to continue on with our tutorial for about another hour. Then we're going to take a little longer break. Then we're going to go back to the tutorial mode, a longer break, and then again we're going to finish up the tutorial. So you already heard the why behind this tutorial. Cleaning messy data at scale sometimes can be cumbersome, and there are tools in Python to help us do this. The learning outcomes, I hope by the end of this tutorial you understand a bit more about the data analytics cycle. I hope you learn how to differentiate between small, medium, large, or big data sets. I really hope that you walk away with knowing how to gather and clean data at scale from this tutorial. So a couple of the things, if you get all set up. The data we're going to be using today comes from inside Airbnb. Inside Airbnb, it's a scraping tool that periodically takes data from Airbnb, from different locations across the globe. I am unsure whether they scrape every single location where Airbnb has business at, but I do know there's quite a ton of data in the website. So you don't need to download anything for the tutorial, but whenever we start on session 00, if you have any issues getting to the data, you can access all of the data already downloaded and decompressed. You can access it with this link. So come back to the repo and then click on link to the data. And this will take you to a treasure or a folder online that will give you access to the data that you can choose from today. So you can, there's all of the countries that are available there. You will find the data in this folder, just in case once we get started with the tutorial, you have issues downloading the data. I don't foresee that there will be any, but you can come back to the repo and access the data through there.
Oh, wow. That is a treasure box. Hey, Ramon.
It's a treasure.
Do you mind taking a look at the chat box and address a question in there?
Yes. Python graph this. I'm not sure, but I see there's a difference between the package name and SciPy. So yeah, so that's interesting. I have can you try with the conda package, Claire, to see if that works with the Python graph this? I cannot recall how I installed this, install the graph base, so I'm very sorry about that. Should be graph bits. Okay, let's check it out. Okay, so apologies about that. So you have to get, it seems that you must install both the GraphBiz system library with the tools apt-get, yum, or brew. So if you have a Mac, you can use brew, install GraphBiz. Let's see, let's actually go straight to GraphBiz. That's a good question. Download. Okay, perfect. Okay, if it worked, then fine. Were you able to install it, Claire? Okay, perfect. So we'll try it out in the session, Claire. And if it doesn't work, let me know. It's not that big a deal. There's only three instances where we use the visualization. I will show them in the screen as well, and you can also always come back to it later on. But that's just to say that it takes a very small portion of it. But I'm sorry that didn't work on the very get go. All right. So I'm gonna ask in the chat: has everyone been able to get the installation? Is everyone done installing everything? Okay. Yep. Okay. Perfect. It is 9:17. I'm gonna give it 3 more minutes so that everyone is all set up, and then I'm actually gonna start with the slides while everyone finishes getting set up. All right. So let's demystify data analytics very quickly. So what we're gonna talk about: what is data analytics? What is a data analyst? How I want you to think about a data analyst. Of course, this is my opinion. Think about it however you like. What does the data analytics cycle looks like, or what are we gonna how we're going to look at the data analytics cycle today. And then at the very end, this can be it. What happens before and after that? All right. So I always like to start with a very famous quote from a famous statistician, late statistician called John Tukey. He says, an approximate answer to the right problem is worth a good deal more than an exact answer to an approximate problem. What does this mean? Sometimes it's when we get to analyzing the data, when we get to manipulate data and pull out insights from the data, we get excited. We really like what we're doing. We find fun stuff in the data. And it's easy to get sidetracked from the major question of a project. So sometimes it's better to, even if you get an approximate answer to the problem you went into the data with, that's much better than getting the exact one to a different question that might not be the underlying reason why you started analyzing the data for. So with that in mind, what is data analytics? I like to think about it as a process for finding questions, answers to questions, interrogating the facts, and evaluating what future things might happen. Usually, data analytics deals more with data that has, or things that have data that has already happened in the past. When we get to data to analyzing things that haven't happened or that will happen in the future, then that we are already in the realm of prediction or inference. So I also like to think of data analytics as information decomposition. If you go to the supermarket and you do a purchase, or you purchase a couple of items, you go to a retail store, purchase some clothing, you're already giving information of that purchase to the retail store or to the supermarket or to a restaurant. And that is already information of things that have happened. When we have that information, we can make inferences about things that have happened in the future. But data analytics is mostly concerned with what has already happened. How do we describe it? How do we maybe come up with better questions to ask out of the data, out of the things that have already happened? Some people like to think it's automatic sometimes. All right, so what is a data analyst? I like to tell my students three metaphors to think about data analysts. So one is as a detective. As a detective, you get a case, your problem, you have facts, your data as a data analyst, and then you analyze that and come up with a conclusion. So in essence, you can think of yourself when you call yourself a data analyst also as a detective of data. You're also, in a way, a historian. A historian is someone that analyzes the past and describes it and tells a story about it. And so is data analytics in a way. And then the last one, you've probably heard the phrase that says data is the new gold. And in that same vein, an alchemist is someone that mutates something or changes the composition of something and makes something else with that. So you can think about that saying of, oh, we get data, we turn it into gold. The data analyst has data, analyzes it, and then turns it into useful information or decisions that make a business impact or decisions that have impact for your business. So in a sense, these are the three metaphors I like to tell people to think about what a data analyst is or what a data analyst do, what data analysts do. Okay, so what does the data analytics cycle looks like? So the first thing is that you put on your detective hat, you come up with an idea, you come up with a project, you come up with a problem. You define, not necessarily very specifically, but you define something that is the essence of your whole project. Once you have that, then once you have what you are trying to solve, then you go into step two. You get the data that you need, and that will help you answer the questions that you have, which is what we're going to do today. We're going to define a problem, we're going to define a project, we're going to get the data we need, and then we're going to analyze that data. So throw it in the bag once you find it. Step three, you clean that data. Most likely, if you found it online, of course, this will depend on the company that you work for, or if it's a personal project or not a personal project. If it is a personal project, you might have to scrape the data yourself because you don't have it available. And if you do, there's chances are that you will have to clean it somehow. If you work at a company that has a data engineering team or that has a data engineer team or somebody that cleans it, that pre-processes the data for you before you get access to it, then you most likely already have a somewhat clean data set, sometimes very clean, and you can get straight into the analysis. Your boss, your manager, your colleague gave you the task. Your data engineering team gave you the data. You get to analyzing it. But there's a step in between analyzing it and between cleaning and actually analyzing it. And that is manipulating the data, transforming it, what nowadays people call feature engineering in the data science arena. So you might have specific representation of the data, but it might be that your analytical model or the inferences that you're trying to make from the data will benefit from having different variables, different features in your data. And that is a step that can be in between the analysis of the data and the cleaning. As I mentioned, it doesn't have to happen in the exact same way, but they're usually one after the other. All right, so are there any meaningful features we can extract, transform from the data? That is one part. Then step 5, get to analyzing your data. Try to come up with things that you couldn't see there before, or try to see what's in it, try to describe it, try to analyze the facts. And then, dig into the data. Step 6, make predictions. Now, this goes a little bit beyond the data analytics cycle in itself. This is the broader spectrum of data analytics. Sometimes a data analyst won't even have to get to making predictions, but they will have to really get to describing the data fast. So this is a step that it depends on what you do and how do you do it, where do you work at, and how does your data analytics cycle look like. Will depend on whether you have this step there or not. It might just be that you jump straight from analyzing it, you jump predictions, and you go straight into reporting your findings, either to your boss. I found this in the data, I found that in the data, here are my results. Now, once you do that, present your findings and gather some feedback so that you can do it better all over again. The next time, either the next time around that you go back into that same project or with a new project, try to do it better the next time. And the step 9, implement that feedback and do it better the next time around. So what does the data analytics cycle looks like? Put on the detective hat, come up with a problem, find the data you need, clean it, analyze it. Maybe if that is the case, make some prediction, make some inferences, try to see what else can you infer from the data. Report your findings, either write a blog post, share it with your friends, do a little presentation, go to a Pi data talk, go to a SciPy talk, gather feedback, do it better the next time around. And then what happens before and after? I mentioned the data engineering part, where if you work at a big company, you might already have people working on getting the data and putting it into a structured way. If that is the case, you probably have data engineers already. Now, in the case of data science, you might be dealing more with the prediction side and the modeling side. You might be building machine learning models. You might be building a chatbot. You might be building a recommendation system. You might be building a lot of things that go beyond the scripted statistics and the what's in the data part of the process. The next thing is software development. Software development, who is going to create the application that is powered by your model? And who is going to connect those things? Now, there's another step, which is machine learning engineering. And in that instance, you really focus, or my understanding of it, you really focus in putting together the best model you can, finding the best parameters, and then deploying the absolute best model possible, fine-tuning it, seeing what can be improved of it. So you're really focused in that last aspect in between the model and the deployment of it, and the monitoring of it. Okay, so data engineering, what does it look like? You have an analytical database. Think back to the supermarket. You have a regular database. Think back at the supermarket example, where you have a database that you shouldn't touch, or where you have a database where all of my transactions, all of your transactions, and everyone else's transactions, when they go to the supermarket, they get tallied down, they go into a database, and your data analyst, data scientist, machine learning engineer, they should not touch that database. They should not work with that one. So the data engineering team usually transforms the data, or not don't necessarily transform the data, but conduct a process called ETL, which is extract, transform, and load. And then they move data into a better format, into what is called sometimes an analytical database. And from that analytical database, then the data analytics, the data science, the machine learning engineers, they can get the data from, and that way they don't corrupt or they don't touch the data that shouldn't be touched, the data that comes from the field. From the field, think about it as from the supermarket, from the retail store, or anywhere else that data gets collected from a transaction. And the next step is data science. How do you get to automating things that solve a problem? How do you define that problem? And when you do, how do you put it into software, or how do you put it into code? Once you put it into code, how do you deploy it? How do you think about a solution one, solution two, solution three? And that in an essence is, I feel like data science is quite a broad term, but you're trying to solve most of the time you're trying to solve a business problem, unless you are in a data science research environment. You're most likely trying to solve a problem, and you're trying to solve it with some sort of automation. Of course, that's my opinion. Okay, so thank you very much, Koshiba. All right, so that is the last of the slides. I believe everyone should be set up right now. Upnote, live Fortran. Tetsuo, I believe. Okay, so Tetsuo and Claire, do you both have Linux? I do. My setup is now okay though. Okay, perfect. Yeah. I have in my personal computer. I'm actually using my work computer. I have Linux as well, and I had the same issue, and I should have addressed that. But thank you for catching that. Is it all good now? Okay. So if you are all ready to go, what I'd like you to do is to go to the notebooks. If you downloaded the code and you have the file, you came here and you either download the zip file or you did it through the command line. I would like you to go to the notebooks, and in the notebook section, open up 00 stage and data, where we're going to talk about, we're going to set up the stage, and then we're going to get the data that we need for this session. All right, is everybody here with me? I'm going to put this side out, this folder down, minimize this, and then I'm going to zoom in a bit more so everybody can see better. Okay, perfect, awesome. So I like to always start my notebooks when I'm teaching with a quote. So here, unless I love this one, I don't know who Ronald Osborne is. I Googled good quotes or great quotes for learning new things, and this one came up and I loved it, so I put it over there and gave him credit for it because it's not my quote. Unless you try to do something beyond what you have already mastered, you will never grow. So the grow part, meaning the large data data sizes, the data at scale that we're going to be working with today. So let's talk about what we're going to cover in this notebook. So the outline for the session, we already talked about what data analytics is. We already talked about what a data analyst is. What does the data analytics cycle looks like? And now we're going to talk about, we're going to jump into what I define small, medium, and big data. Beyond that, what we're going to do is we're going to define the problem that we're going to be working on. Once we define the problem, we're going to get the data together. Once we get the data together, then we're going to start the cleaning process, and we're going to put it into a nice format that we can access it from. All right. Then we're going to summarize everything in this notebook. There's some questions at the end that I hope you come back and check. And then we're going to jump into the next notebook where the core of this tutorial is going to take place. We're going to start cleaning this messy data set. So All right, we saw what data analytics is already. If you, one last thing, if you also have access, I put the link to the slides in the chat, but you also have all of the images in the folder that you downloaded, in the directory that you downloaded. You have all of the slides from that presentation as well. So you can check it out over there as well if you like. All right, so what is a data analyst? We covered this: the detective, the historian, the alchemist, the data analytics cycle. Now let's talk about small, medium, and big data. The way I define, see, is there a setup? No, Tetsuo, let's check it out. Okay, hold on. So if you have issue, maybe the environment, that YML has specific packages not available. Okay, Tetsuo, let me know if you're able to install them with the pip command or the conda command at the very bottom of the getting started section of the repo. So check and see if you can get it installed either with the conda install command or with the pip install one. And let me know if that works. All right, so let's talk about small, medium, and big data. So nowadays we generate data on a daily basis. We use our phones for almost everything. We use our computer. We take our personal laptops anywhere, and anytime we interact with an application, every time we go and visit a website, we are generating data in some way or another. So that means that the size of the data is also increasing at a quite fast rate. So our computers are not moving at the same speed at with which data is increasing in size. And sometimes that means that the amount of data that we can fit into memory on a regular computer is limited as well. So we cannot analyze these many large data sets. So what is small data? Or how can we think about small data? I like to think of small data as the data that can fit into your computer. Usually computers nowadays, they have anywhere between 8 gigabytes of memory RAM and 16 gigabytes of memory RAM. And what that means is that if you have 8, you have to be able, or you should be able to analyze anything below that number. Usually 7 and below, that should be good for your computer. More than that, you will not be able to. Your computer might just crash because it cannot hold all of that into memory. Now, there's the next stage where you cannot fit the data into your memory, and that's what I call medium-sized data, or not just me, but a lot of people. I do put it between 10 gigabytes and 80 gigabytes. That's the most I've managed with Dask in my computer, but I've also let it run for almost the entire night. And that was about as max as I could get in a computer with 8 cores and 8 gigs of RAM. But of course, this will depend on your computer. So it might be that you are able to manage easily or more easily between 15 and 150 gigs of data processed in parallel on your computer. But it will depend. So that's sort of the range that I like to think about medium-sized data. And then large data, it doesn't fit in my computer. It doesn't fit in your computer. It doesn't fit in everyone else's in this session's computer. And that's usually where we go into tools such as Dask for help, and Spark, which is another great tool, the MapReduce framework, Hadoop, and many other tools that help us analyze data in clusters of machines. Now, that comes with quite a few complexities. I like to think of it as a very intensive engineering process. Of course, it doesn't have to be, but it can certainly be. And yeah, that's sort of the way I like to think about big data. You might have a different definition of it, and that's completely fine. All right. So let's go ahead, and before we go into break, let's go ahead and define the problem for today. So I want you to put on the detective hat and think about this. We are sick and tired of COVID. Of course, I mean it's been a very turbulent year to say the least. So we want to get started planning our next vacation. Now, we want to scratch some items or some countries we like to visit from our bucket list. And since things can be quite costly, maybe they won't be because um, the hotel industry and the tourism industry has not been at the best this year because of COVID and travel restrictions and all of that. It might be that you might find some very cheap deals, but we don't want to spend too much money. So we want to go to and find really good deals in Airbnb and try to, I don't know, find, not necessarily just find the best deal, but compare the best deals that we find in our top three choices or the top three countries that we would like to visit. Okay, so the project goal: find the best place to stay at for our next vacation in terms of costs, venue, and things to do around it, given our top three destinations for 2021. Of course, we're already canceling 2020. We don't care about 2020 anymore to some extent. And so today, what we will cover out of this broad project, we don't have any hypothesis set up yet. We haven't really thought that far ahead, but we have a problem or we have a goal that we want to achieve. Today, what we will cover is the grueling process of collecting and cleaning the data. Now, I mentioned that the data comes from an awesome tool called Inside Airbnb, and you can access Inside Airbnb by clicking on that link. You can go straight to their website. As I mentioned, they periodically collect data from all of the locations where Airbnb has listings at all across the globe. So I believe for Australia, we have quite a few around all of the major cities in Australia. In Europe, there's pretty much all of them. Japan, I believe the only location in Japan is Tokyo, or at least the only location inside Airbnb. And we're going to be using that one today as well because SciPy Japan. I also want to go to Japan. So I was really hoping that COVID aside, that I would have been able to make it to Japan. So still on the bucket list. So let's go ahead and get the data. So it is 9:40 Japan. We have a little break schedule. So let's go ahead and take a short 5-minute break. And it is 9:40 Japan. Let's come back at 9:45, okay? If you have any questions, I'm here. Okay, awesome, Tetsu. I'm glad you were able to get it going. Fantastic. I'm gonna stay here. If you have any questions, let me know. Claire, you had issues with beautiful soup. I completely agree, Claire. Tetsuo, since you have Ubuntu as well, at the top, before we get started, and you might be on break right now, but so I'm going to put it at the top of the import commands. You might need to install Beautiful Soup. So I'm going to say for Ubuntu or Linux users. Did you use BS4 or Claire, or did you use, or was it actually Beautiful Soup? Beautiful Soup 4. Okay, perfect. Okay, so Tetsuo, make sure, since you have Ubuntu as well, make sure you run this one first. Pip install Beautiful Soup 4. All right, so let's get going. So it is 9:45 Japan. Let's continue on with the session. So the first thing we're going to do, we're going to be using several libraries in Python. One of them is pandas. I'm going to talk a little bit more about the data structure in pandas. For this tutorial, it was not required that you knew pandas beforehand, nor that you know APM, NumPy, or Dask, of course. So I'm going to be explaining the main data structures of pandas, which are mostly panda series and pandas data frames. I'm going to explain those two, but we're going to import them with their industry alias. Think of an alias as the nickname. We're going to use globe to get some files from our folders, from our directories. We're going to use URL lib to get the data from inside Airbnb. And one of the ways I like to reason about some functions that I'm going to be sending to, or that I'm going to be using in parallel, is by adding the type right next to them. So for some of them, I am using type hints. So we're going to import those two from the typing module of Python, from the standard library. Now, one more thing I'd like to mention, inside Airbnb, when you go to get the data, to get the data section, you are presented with before we even get the data, you are presented with a ton of information. So you not only have data for Amsterdam and the last time it was scraped, but you also have data on the detailed calendar for the listings of Amsterdam, reviews data for the hosts. Now that's a little bit trickier one, because you need a unique identifier for the host, and then you need all of the comments for that specific host. We won't get into that one today, but what we're interested in the listings, in the information that contains where we will stay, how much will we pay, what is the cleaning fee, what are the do they have a security deposit, what is the area in which this listing is at. So we want to find a good place to stay, and we want to find a place that is in a zone or in an area where we can move around to. Since we're going to do some sightseeing, we're going to be exploring the country that's in our bucket list. We want to be able to get that information in a nice data set that we can analyze in a nice tabular format. All right, so that's the information that we have, but not only do we have it for every single city that Airbnb has data, or not that Airbnb has listings at, but we also have the archive data. So since we need the one called listings.csv.gz, we might encounter quite a lot of values or quite a lot of links with this specific name. So more concretely, if you look at here, the column called date compile, the last time that Airbnb scraped Amsterdam was in September 9th, 2020. And then the one before that for all of the listings was on the 18th of August, 2020. So that one is quite close to each other if you think about it, with just 12, 9, 21 days, about 21 days difference. So about 3 weeks difference between the scraping of one of the last time and the one before that one. The same happens for a lot of the other cities that Airbnb has listing or does business at. And because we don't want all of that massive information, there's going to be some pre-processing before we get the data and some pre-processing after we get the data. So let's go right into it. And let's start by importing the modules and the libraries that we will be using. Now, pandas by default collapses or reduces the amount of columns that it shows you for a data set. So we're going to use this option here that says, don't put any maximum on the number of columns that pandas will show to me when I read my data frame or my data in. Okay, another thing, we're going to create a path to a folder that you probably don't have right now. If you are on a Windows computer, make sure to uncomment this one by taking the hash out, and then comment this one by putting the hash on top of the path. Since we don't have a folder yet called data, we will create one here in a second. So don't worry if you don't see it in your Jupyter session. It will be there very soon. The next thing we're going to do, we're going to create a little function. And then this little function, when we're working with a lot of data or when we're working in a data analytics project, either we create all of the folders and all of the directories where results, specific results, data, samples, files, functions, utilities, all of the things that we're going to be working with will live, we'll create those directories maybe at the beginning of the project, at the very beginning, or throughout the project. Now, when I'm in a session, in a Jupyter session, working with Python, writing code, I create a lot of stuff on the fly. I try to do a lot of experimentation. I write a lot of code. Sometimes it's messy, but it's understandable to me. And then at the end of the day, I have to go back and clean it. But one thing that I don't want to recreate from scratch is the folders where either the clean data will live at or the information that's going to be most useful for me and my colleagues be at. Because of this, we're going to create a little function that checks whether a path already exists. And if it doesn't, it's going to add that new path that we're adding to the function, and the rest of the files or the rest of the names that we add are all going to be optional. And we can add as many as we like. So we can create different directories, different folders recursively. Okay, the next part of that, if that path doesn't exist, then we will create it and we will join it with the new arguments inside our function. If you've never seen the star in front of an args call in Python, this means that this is sort of a unique way of Python of saying it doesn't matter how many arguments I'm going to put in here, unpack them all. And the little wildcard, or it's not necessarily a wildcard in this instance, is a star, says, okay, move them all, use all of them in this particular parameter. So that's exactly what we're telling Python. It doesn't matter how many we add, just create the folders that we need. So we're going to run this function. And then we're going to go to the next one. We're going to use the request module. The request module is very, very popular, very, very useful, and it allows us to get data to make an HTML, to make a call to a website, and then get back a result from that website. So this is, I believe, the only other cell in the notebook that has forward slashes as opposed to backward slashes. So please note that if you have a Windows computer right now, make sure you uncomment the one at the bottom. Actually, I don't even think you need to uncomment this one. I don't worry about that one. That is actually a website, not a folder. So that's fine. So we're going to use the request that get. If you at any point have a question about a function, you can go to the beginning of the function or inside the function, and you can press Shift Tab, and it will give you the doc string of that particular function, method, or whatever tool you're using. Another way in which you can do so, if you have never used Jupyter Notebooks or Jupyter Lab, you can add a new cell, and you can take the module or the function that you are trying to use. You can start typing it, and you can press Tab, and then Jupyter Notebook will finish writing, or will finish getting what you need. The other thing that you can do, you can add a question mark at the end, and you will get the same doc string. So just in case you have questions throughout what is something doing, and I don't stop to explain every single one of them, make sure that you add a question mark at the top, or that you go in front of the get, or in front of the function, and press Shift Tab to get the doc string. All right, so we're going to make a request to inside Airbnb, get the data, run this cell. Now, it might take a second to get it. Once you get it, notice that your 4 finishes. And then what we're going to do is that we are going to create the path, the data folder that we mentioned a second ago, that we added to the variable path. And then we're going to create another one called raw files, where all of our raw files are going to live at. We can actually copy that and print the file that we are creating. Oops, I have not run my path up here. I need to run that. Now I can create my path. And there you go. Now we have a data folder, and we have another raw files folder inside that data folder. The next thing we're going to do is we are going to write the results or our request from inside Airbnb. We're going to add it. We're going to write it as text in our new folder, in our raw files data. We're going to do it in context manager. We're going to give it the name inside Airbnb.html. We're going to write. We're going to use an alias for this, and then we're going to call the method write. Now, when you get data from request, you have an attribute method called text. That text is what we're going to write out. If you go to your folder, to the data folder, and you click on raw files, you should see a file called inside Airbnb.html. Okay, so the next thing we're going to do is we're going to create a path to we're going to create a new variable, and that variable is going to have the entire path to our new file. We're going to call it HTML doc. So now we are collecting this file, and just in case you don't want to download it again, if you close out of your notebook, of your session, you should always have access to this. The next thing we're going to do, we're going to use Beautiful Soup. We're going to pass in the file that we are reading in, that we are opening up, and we're going to call the HTML parser. We're going to use the HTML parser from Beautiful Soup. This one might take a second, but Beautiful Soup is a very, very useful and very nice library in Python, or package in Python, that allows you to scrape data from the web, and it gives you a lot of useful functionalities, useful and straightforward functionalities for accessing the elements inside scrape data, or inside the skeleton of a website. In this case, an HTML file. So the next thing we're going to do, if you have seen this before, this is a list comprehension in Python. It is an inverted loop that always gives you back a list. And what we're doing is we are saying, for every single A element, or A element inside this HTML file, I want you to grab the hyperlink references to those elements. And then I want you to add them to a list. So we're going to run this one. And now you should have all of the files. Notice that the very first file that we know we want is the Netherlands, Amsterdam, from the Netherlands. And we want the listings.csv. Because we won't be using the Netherlands right now, the data from the Netherlands right now, but it is useful to know that we got every single link we wanted plus more. So if we wanted to get the reviews, if we wanted to get something else, we could also come back here and do so as well. Let's see how many links we got. Okay, we have 20,499 links. That is a lot of links and a lot of information. Let's see if we can prune that down a bit more, because as you can tell up here, not every single link we grab is actually useful for our purposes of getting the data. We're going to be, if we were to use all of the data in Airbnb, which I believe inside Airbnb, which I believe it amounts to 160 gigs, the decompressed listings, it would take quite a bit of time, and we definitely don't want all of these links. We just want the listings. So the next thing we're going to do, we're going to add the list. We could write, to get rid of all of these links that we don't want, we could write a regular expression and then pass it through that list, and then get all of the files that end with listings.csv.gz. But of course, pandas is even more convenient, because every list of elements or every array, if it's an object, if it's a string, pandas gives you the ability to use string methods on those arrays directly. So we don't have to start writing a matching pattern with the regular expression module. We can just do so all together in pandas. And because pandas is a core part of Dask, Dask parallelizes pandas data structures. It is good to get an introduction to it right now, especially if you don't have any experience using these tools before. So what is a panda series? A panda series is an array, one-dimensional array with a very visible index and very malleable as well. While with the list, you have an index that goes from 0 to the length of that list. With panda series, you can have an index that has a textual value. You can have ice cream flavors for an index. You can have countries for an index. And you can have numbers as well. You can also filter given that specific index, in the same way you would do so with regular list. So let's see what this looks like. Now, I am not adding the series to a variable for example purposes, but we will do so here in just a second. So now, as you can see, we have a very visible index, and we have a data type of int64 for our all of the elements inside our series. We can also have series in the same fashion as with list, Python regular lists, and we can give them a name. And the name would appear right next to the data type. There is an error with the HTML. Did anyone get an error with the HTML write method? So Rocco, what I can do is what I'm going to do, Rocco, is that I am going to upload that file into tutorials. Okay, Rocco, if you had any issues with getting the inside Airbnb HTML file, it is now available in the treasure in the repo. So if you go to the treasure, if you go to the repo, sorry, Rocco, so go to where all the information lives. Go all the way down. Go all the way down to where it says data, the data section, and then in the data section, click on link to data. Once you click on link to data, go all the way to the bottom of that treasure. And then at the very end, you're going to find the inside Airbnb.html file. Let me know if that works when you get to it. Now it is available for you. All right. So as you can see here, we can add strings normally, as we normally would inside a list. And then the next thing we can do is that we can index into them or get elements out in the same way that we would with regular Python lists. In this instance, we took Japan out of our same series from up here. We're gonna create a toy series with a lot of numbers. And the next thing that we can do is that we can show the very first couple of numbers using the head method. The head method doesn't take any, if you don't pass any parameter to it, it will return the first 5 elements. Now, this is very important because we're gonna use it throughout the tutorial. Awesome, Rocco, perfect. We're gonna use this throughout the tutorial. We're gonna be masking, we're gonna be creating conditions and filtering and selecting data using this mask, what is called a mask or a condition. So right now I have a toy series. This toy series has 100 numbers from 0 all the way up to, but not including 100. So from 0 to 99. If I want to select only the numbers that have greater than 30, a value greater than 30, then I can create what is called a condition. This will return a Boolean array of values that will be false for those that are below 30 and true for those that are above, but not including 30. So now I have my array of Booleans. I can pass in this array of Booleans inside brackets. And inside these brackets, what's going to happen is that Python or Pandas is only going to select those elements for which the condition is true, and is going to take out or deselect or not select the ones for which it is false. Oops, this is supposed to be condition 1. So if you have just condition, make sure you put condition 1. And now we can also see the exact same index. So if you have condition, make sure you put condition 1 there. Now we have the same index for the or we still have the same index for the numbers that we selected through a condition. And we can also do it by combining multiple conditions using the AND operator and the pipe operator, which represent the same Python AND and OR, but I forget the difference of why do we use this one as opposed to the AND and the OR in Python, but it works. One of the things that you need to keep in mind is that you have to wrap the conditions in parentheses or round brackets in between the AND operator, especially, so here we are selecting 2 conditions. We are saying, give me the elements that are greater than 30, but that are also less than 60. So right now, our list should only go from 30 all the way, from 31 all the way up to, but not including 60. And that's exactly what we have here. So that is how you combine multiple conditions or multiple masks into an array using pandas. Now with the OR, imagine that we can also pass, instead of passing a straightforward variable, we can also use the exact same code inside the parentheses or round brackets, the pipe, parentheses, and the condition, and then inside the square brackets. So we can do the exact same thing, and we can pass a pipe. And here we are selecting those who are greater than 60 and those which are less than 30. So we should have now in our array only numbers from 0 all the way up to 29, and from 61 all the way to up to 99. Okay, so now time to get back into what we want. We created a variable called list of links. If you remember, our list of links has all of the files. I'm gonna add a slicing. I'm gonna add the list here in case I forgot what I had. I'm gonna select from 0 all the way up to 14. And then we know that we have all of the files that we want. Here are the listings.csv.gz. Those are the ones that we are interested in. So what we're gonna do, we're gonna create a panda series, a one-dimensional array. We're gonna view the first 10 elements to make sure that everything matches what we have in our list, just to make sure. So everything matches. Now Python pandas narrows down the view of it, but we know that we have the data we want. We just pass in the list that we needed. So what we're going to do now, we're going to first check whether we have missing values in this list before we pass in the string method. And the reason why we do this is because NaN values, or non-available numbers, or non-numeric, not a number values, are represented as float 64 in Python. And because we're going to pass a string method, we don't want to have any missing values. Plus, this is a list of links that we want to iterate over. We don't have a need for a missing value, and it doesn't represent anything in this case. So let's check how many missing values do we have in this list. We have about 101. What we're going to do, we're going to use the pandas method called dropNA. Remember, if at any point, any function or any parameter, you can add new cells at the very top. If you want to check something, if at any point, any function or any parameter seems a little bit mysterious, or I don't explain it the way I should explain, or I don't give too much insight as to what it might be, make sure you copy it, paste it into a new cell, and either put one question mark or 2 question marks to check out the docstring of such document. And it will tell you everything about the formula or about the function. For example, in this one, it says it returns a series with missing values removed. That is exactly what we want. I'm going to right click here and clear the output of that explanation. You can also use Shift Tab and check out the string, the docstring inside of the function. So I am saying in place because I don't want to reassign this list into another list. I wanted to keep the change in the same variable. Now, the next thing we're doing is we are calling in this panda series, we're calling the string method. With the string method, we are calling the ends with. So what we're trying to do is if the element, if the row or the element at whatever index ends with listings.csv.gz, we're going to find it. Give me a Boolean column for this. And if it does, then we're going to pass. So for all of those that are true and they do end with listings.csv.gz, we're going to pass in that condition. And then we're going to reset the index just because we can. We don't have to reset the index. But if you don't reset the index, then you're going to have sort of whatever was taken out is going to be out of your list. It doesn't really matter, to be frank. I'm just resetting it because I can. So we're going to pass the condition. We're going to add it into a new variable called files we want, and we're going to examine the first 5 elements. Okay, so now we have the data that we need. We have the files that we need. We have everything we want, or what we're going to use to get the data. So this is awesome. Let's look at the shape. If you want to look at the shape, how many columns and how many rows data a panda series or a pandas data frame has, you can use the that shape method. Of course, because we have a one-dimensional array, we're only going to have the rows element, but it is good to know that you can see both the shape of your matrix or your data frame using the that shape method attribute. Sorry. So we went from 20K, from about 20K links, hyperlinks inside Airbnb. And I'm assuming that has a lot to do with the archive, with the massive archive that they have. So I'm still scrolling here and I am still in just Amsterdam. I can only imagine, for example, San Francisco, New York, and all of the values that they're going to have in terms of, there you go. So for example, this is still Amsterdam, but you also have Chicago. I can only imagine if I click on the show archive data for Chicago and all of those cities around the US, for example, where Airbnb has been doing business or has been at for quite a while. It must be a lot. So we went from 20K files or hyperlinks inside this get the data from inside Airbnb to just about 2,000. Sorry, just about 3,000. All right, so what we're gonna do now, remember, we don't wanna write a complicated regular expression, which we could, and we could have just used our pandas or Python regular list data structure, but Pandas gives us these really convenient string methods that we can take advantage of. And one of those is the split. We can split by a specific element, and once we do so, we can select a grouping that comes out of that element. So, say for example, we have our files here. This is the first forward slash. This is the second forward slash. This is the third forward slash over here. So what does it mean by a group? The first group, or group 0, is going to be the very first element before they find the forward slash. The second one is going to be between the first slash that it forward slash that it found, and then the second one. Then the third one between the second one and the third. I know that sounds a bit confusing, but to put it concretely, HTTP is going to be the very first group. The space in between the next two slashes is going to be the next one, the next group. Data inside Airbnb is going to be the third group or the second group, because Python enumerates things from 0 and up. So HTTP 0, 1, 2, and then the name of the country we're interested in, 3. So that's exactly what we want. I'm going to add a new cell up here, and then I'm going to put the files we want to show what that will give us. Let me copy these. So we get a list. So we get a different data structure. So exactly what I was just mentioning, it separates every element that it finds before and in between and after what we're splitting by. In this case, the forward slash. So then there's another element, there's another grouping, and then there's another grouping here. So we're going to get the group 3. We're going to examine the countries. Notice that now we have the Netherlands and all the way down to Australia, where I am at today. So what we want now, we won't do much with just the names of the countries. What we want to know with all of the names of the countries and how many times they are repeated, what we want to know is, okay, which countries do we have in this data set? What countries can we pick and choose data from? Remember, our goal is to find the next best vacation where COVID ends. We're very excited for COVID to be far away from us. So what we want to do, let's check out the unique countries that we have in our data set. We have the Netherlands, we have Belgium, we have the United States, we have Greece, Spain, all the way down to Austria, Japan, Taiwan. So we have quite a lot of countries to choose from. And what we're going to do now, let's check and see how many files do we have for each one of these countries, because that's probably one of the things that we're most interested in. We want to know, okay, if I'm going to be downloading all of these files, what am I looking at? How many gigabytes is that? What is that going to mean? How many files? What are the sizes of each individually, and what is the total? So what we're going to do is we're going to create another Boolean, another condition, and we're going to pass it through a loop. So we're going to loop over our list of unique countries. Every element inside that list, we're going to call it country. If you recall your for loops, you can name the variable that is going to iterate over your iterable or data structure, in our case, a Panda series, or this one is actually a NumPy array. And we're going to create, using our countries variable that has the same length as the links we want. We're going to say, if you find this country, in this case, for example, the United States, I'm going to run this cell at the top. Give me a Boolean. And for all of the Booleans that you find, I want to see the length of all of those. And that is how we're going to count the amount of files that we have per country. We're going to find the instance where that country is at in our list. And we're going to take the length of all of the elements that add to 1, that have a 1. False and true in Python are also represented as 0 and 1. And that's where we are able to count the instances of 1. Okay, so let's run our loop and let's see what we have for the countries. All right, so for the Netherlands, we have 58, Belgium 83, the United States, which doesn't really surprise me, is where Airbnb started at, seems to have the most amount of countries, and listings, and it certainly does. 859 files. That is a lot of files. That is a lot of data. And actually, you can look at the treasure folder that I have available with everyone. And in the United States, I believe it gives you the size of the data. The raw files, no, it might not tell me the size. I cannot recall how to check it out. But we have a table here coming up soon, actually, that we can see the size of the US files. So that's fine. China, 57, Belize, 15, Italy, 240 and 46. So actually we have quite a few countries that have over 200, for which we have more than 200 files that we could download. So that is a lot of data to play with. And we are certainly going to take advantage of it today. All right. So first exercise for you, I want you to find out how many unique cities are represented in our data set and add them to a list or to a pandas series, whatever you like. Assign this list of unique cities, it can be a NumPy array as well, to a variable called unique cities. So you're going to call that variable unique cities. Hint, look at how we just did this above, because it's a very similar step on how to get the countries. The countries was group 3. So which one would it be? Which group would it be for the cities? If you go back to the links, we have the Netherlands, the name of the country. North Holland seems to be the particular region or the particular area where the city Amsterdam is at. So that is too many clues. If you get stuck, I'm going to give you about 7 minutes for this exercise. And then I want you to print the cities and how many files do we have for each. And remember, we use something similar here for the countries. So that's the first exercise. If you get stuck, the answers are here in the ellipses. You can click on the ellipses and see the answers, but try doing it yourself. And I'm going to give you about 7 minutes. So let me know as soon as you are done. If you got any questions, please let me know in the chat. Once you're done, hold on for a second before you put the answer. I would love for you to put the answer in the chat, but once the timer is done. I've seen so many videos of SciPy, and it seems like a lot of fun just to go to check on everyone when everyone's at their tables and coding away on the exercise and asking, "Hey, how's it going? How are you doing?" And everybody finds a cool solution to an exercise that you couldn't even think of. So I really wish that we would have had. COVID wasn't here. COVID aside, that we would have met. I would have met all of you in person. That would have been a lot of fun. So for the next year, for SciPy Japan 2021.
Yep, that's the hope, Ramon.
That's the hope. By the way, happy Halloween, everyone. It's October 31st.
Oh yeah, I guess it depends on which time zone are you.
But yes, it definitely does. What time is it over there in Central Daytime?
We are 8:25 p.m. right here.
8:25. Gotcha.
Mm-hmm. I have pumpkins at home, wait to be carved tomorrow.
Nice. That's awesome. That's awesome. Such a fun tradition. I believe that's mostly done only in the U.S.
Really? I thought it's
No, I said I wonder. I don't know.
Oh, I don't know. Are you gonna put on your costume anytime soon?
Well, I hope so. So I have a class. So right now I have one of my colleagues teaching one of my classes. So after the session, I go back to teaching, and then hopefully, yeah, tonight do something fun for Halloween. Find a costume, and I have a few choices. So let's see what I pick.
Nice.
I'm excited. I love Halloween, so I'm really excited.
Nice.
Are you gonna do anything, Warner?
We're gonna carve some pumpkins,
Aside
and
from-
yeah. So the best part is after, and then we will build some gingerbread houses for Christmas, and then after that, we're gonna take them to a friend's land, and then we're gonna blow it all up.
Oh, that sounds pretty cool.
It's a Texas thing.
It's a Texas thing.
Yes.
So you have become a Texan now.
Right. And you blow up some pumpkins and the cows will eat them. So everybody has a good holiday.
I asked this to Kristen. Do you have your cowboy boots already?
You know what? Not yet. I need them. I need some.
You need some in Texas.
Yeah.
All right, so you got about 1 minute left. If you are done, let me know in the chat, and we will move on. All righty, so that's it. So can anybody share their answer with me in the chat? Did you pick at the answers below, or what did you come up with? Oh yes, that is true. That is quite a nice shortcut actually. I didn't think of that. That's awesome. Okay, so I think Claire did. Okay, so files. Let's say if we were to call it cities, we want, and then we were to do from files, we want. We were to do the string method, and then contain, or actually ends with, not ends with, split. And we were to split and get the fifth group, get fifth group. So we have the cities we want. And then Claire's solution was actually very freaking cool. We don't need, and it's so simple and it's so straightforward. We don't really need, actually, did I get the right one? Split. Oops. Oh, I need to call the STR again. STR, get, there you go. Now we have the cities, and Claire's solution was much better than having to write a for loop, and that is value counts. Fantastic. This is great. Awesome. All right. So, oh, but we need to call the unique first and then value counts. I see. I see. So that's pretty good too. Because you could actually call the unique on it. All right. So let's uncover this one. So I had something very similar. Get the fifth group. Get the cities that are unique. Using the same way with, okay, Amsterdam has 58, etc. Using the same way with country. Yes, yes. And so as you can see, actually, so that's a good observation, Tetsuo. There's actually countries that only have one city. So even if you saw a specific number in the country's unique numbers or amount of files, you will also see the same amount of files for the city that we have from that country. For example, Japan and Tokyo, South Cape Town, South Africa, and I believe there's quite a few, Belize maybe, and quite a few others. So yeah, so that's the cities we want. Okay, so now we are going to pick 3 countries. These are the ones that I have picked for the tutorial today. When we get to the 2 challenges that we have for you, one at the end of this notebook, one at the end of the next notebook, you get to pick your own countries so that you can start your own project with data from Airbnb, and you can start planning where you're going to travel next. Once it's safer and easier to travel beyond COVID. So 2021. All right. So let's create 3 variables: my country, the first one, my country 2, and then my city. Even though, so I feel like I'm kind of cheating on this one because South Africa only has city. This is the only city that South Africa has inside Airbnb, but they do have other cities actually listed in South Africa. I checked in Airbnb. All right, so we're gonna create these three variables. Then we're gonna create a function where we use the unique country. So this function does rely on the variables that we just created, namely unique countries, the very first one, and then the second one, unique cities. But if you did name them in that way, then you have then the function will work just fine. It's sort of a quick and easy way to check how many files we have for a specific country. Of course, we have them in our loop up here, so we can come back and refer to it if we want to know the length of files in a country or specific city. I as well have added a table for all of you to check that has the name of the country, the amount of cities, the amount of files available, the decompressed size, and the compressed size of the files. So to make it easier on you when we get to the point where you're going to be working on your challenge for today on one of them. All right, so let's run this function. And then we're going to add the country. We're going to add the method title to our variable with our countries. So to print it a little bit nicer with the capital letter at the very beginning. Then we are going to call the function using, this is an F string. If you have ever seen this one in Python, they allow you to pass arguments inside the string where you can evaluate either some functions or specific statements or pass in variables. So we're going to call it on our 3 files just to check and see how many values do we have for each, or how many files do we have for each. So for Japan, we have 16 files. For Belgium, we have 83. For Cape Town, we have 24. Okay, so now we're jumping into the main function for this entire notebook, or one of the main functions for this entire notebook. What this function does is that it takes a Panda series. And I mentioned at the very beginning that sometimes I love the fact that I don't need to specify the data type of inside of an argument inside a function. It is very useful for fast prototyping and writing code and test stuff on the fly, test things on the fly. But it's also very useful and convenient to have at the same time the ability to add types to your code. So if this seems a little foreign to you, the colon and then the data type of what is being passed into the function, I'm going to explain it here to break it down. So the very first thing is when you want to pass in an argument to a function, that argument is going to have a data type. It could be, if we don't specify what it is, if somebody puts an integer while the function is expecting a string, or somebody puts a float in a function that is expecting another function, then we might get an error. When you run functions in parallel, this one is not going into in parallel, but when you run functions in parallel, sometimes it's difficult to reason as to what your code might be doing. And when you add the data type next to the name of the argument, that allows you to reason or visually see and reason through, work through what is my function actually taking in and what is my function giving out. So let's walk through it. The first thing is the URLs. The URLs right now is inside our Panda series. So we are going to pass in, we have an argument that is called URLs, and it takes in a Panda series. We need a country or a city. So we have an argument called country city. That argument is a string. The colon signifies or splits the name of the argument between its data type. The path to files is a piece of string where we're going to save our data. The country city unique is the iterable, which could be a Panda series. It could be a NumPy array. It could be a pandas list. It could be a set. It could be a tuple. It's going to be an iterable. So anything we can iterate over, that's going to be the unique country or city list that we just created a second ago. Now, the unique number means that if you specify that you want a unique, if you don't specify that you want a unique amount of numbers, look back at, we have 16 files from Japan. If we want all 16 files, we leave the default value of none from our unique num argument. If we do want a specific amount of files to download, then we say, oh, I only want 10, or I only want 13, or I only want 14, and so forth. So we don't want to download the entire file amount of files from Belgium. We don't want to do so as well with Cape Town. We want to get a manageable amount of files, at least for our session. Now, the last thing is that after, so we start with one round bracket or parentheses, we end up with another round bracket or parentheses at the very end, and then we tell Python, what is this function giving us back? We don't need anything from this function. This function is going to give us the data. So we don't need anything, and I pass that on to it. So this is what helped me reason about what kind of function did I need. So what we're going to do is we're going to give it our new 3 variables that are called my country 2, and my city. Our function is going to check whether that city is in our iterable of unique cities or unique countries. If it is, it's going to create a condition with our URLs Panda series. Is going to create a condition where that country that we just passed in belongs or is contained in a specific path or a specific URL. The files for which we're going to get data from, or that we're going to use to get data from. Once we create that condition true for the links that contain the country that we want, we create a condition, we create the new, we filter out those we don't want. And then we check, remember our check or add path to files function. So this function depends on that one as well to create a new file. So our path to files is going to be where the data lives. We're going to add a directory inside that data folder with the name of the country that we're passing into our function and underscore data to signify that in that new directory, we are going to put data, and that this data that we're going to put in right now is raw data. So we're going to create two folders or 2 directories in this code. Now, if you pass in a unique number, we're going to start counting, and we're going to get up until, but not including, the number that you added. If you say I want 10, well, Python is going to go from 0 to all the way to 9 and not including the number 10. And what it's going to do is it's going to use wget to download the data. Now, it's going to select with the iloc. Iloc is integer location for a specific file in a Panda series. What this means is, if you recall from earlier, a Panda series has a visible index. It has an index that we can see and that we can manipulate. That index can be accessed with an integer location, by an integer location. So whether it is a string, whether it is a date, whether it is what it is, whatever it is. If we say iloc, integer location, which I believe that's the right name of it. It might be another, the I might represent something else, but this is certainly location for that index. It might be index location. So we're going to select that same number, that here is a 0, and we're going to start getting that data. We will download it into our new directory. This new directory was created up here. Now, the name of this file is going to be the name of the country or city .csv.gz, signifying that it's a CSV file that is compressed right now. If that wget doesn't work, which for some reason it doesn't with some of the files, then it's going to default to urllib, and it's going to request and it's going to retrieve the file. That happened to me with when I was creating this with some of the files for Japan and some others, and some work here and some work here and some didn't work here and some didn't work here. But with both, all of them work. And that is the reason why you can see all of the files in the treasure it, because both work fine, but one will break at some points and the other will break where the other wouldn't. I haven't explored why. So if you don't pass in the number, you're going to download all of the data available for that country. So it's very important that we pass in the number. If you want to get all of the data at some point where you are at home working on this tutorial, and you are at home working on all this, you want to get all of the data, and you want to have a treasure, just like the one I downloaded earlier, or I showed you. This might take you, it's about 160 gigabytes of compressed files. So this will take you about, with my internet speed, it took me about 2.5 hours. So you can use this function, you can copy it and put it somewhere, and you will download all of the data that is available inside Airbnb. So once you started off with your project, I highly recommend you do so. Okay, so here is the list that I mentioned a little bit ago before we jump in, because you will come back here for your challenge once we finish this notebook. So here is the list of the information you should know about this data set, or very useful information. So per country, you have a specific amount of cities. Tetsuo mentioned this a little bit ago, that Amsterdam had this amount of files, and then the country as well. So it's sort of the same thing. If you have one city, and then you have one country, then they're both going to have the same amount of files. So compressed size, you have 851 megabytes for the Netherlands, but then you have decompressed size of 3.6 gigabytes. So for the US, it's quite a large amount of files and amount of data. And remember, we're not even counting the reviews, and we're not even counting a few other things that Inside Airbnb provides us with. This is the listings. This is the sort of where most of the information we're interested in for our goal for today lives at, the listings. So this is a good reference if you want to check out what you have and what you don't have when you come back to it, and the size that you can deal with in your computer. So for ours, remember, we are using South Africa, we are using Japan, SciPy Japan, and we are using, Belgium. All right, so the next thing we're going to do, we're going to run our function. This is going to take about 2.5 minutes, depending on your internet speed. Mine is not the greatest, and it took me about 2.5 minutes. So we are going to run this. Oops, we got to run the function first. So make sure you run the function. So come back here if you haven't. Run our big function for get me specific data. Then come back down and run the function. Notice what's happening here. We have our pandas series with all of our URLs to download the data. We have our country. We have the path to the data. We have our list, our NumPy array of unique countries, and our other NumPy array of unique cities. Remember, if you don't have this specific array of unique cities, you can either no, you cannot change it to that one because we already put Cape Town. What you can do is go to the exercise 1 and make sure you run the 2 answers for exercise 1. So now we're going to run this one. It's going to take about 2.5 minutes. And I think this is exactly when we mentioned we would take a break then. So that's exactly what we're going to do. It is, let's see, instructions 10:45. So it is exactly 10:45 Japan time. So we're gonna take a longer break now, and we're gonna come back in 15 minutes. What a good spot to take a break. Perfect. So if this function, if you had any issues with the function or anything, let me know on the chat, and we're gonna take a quick or a longer break, a 15-minute break. Okay.
Perfect. See you back in 15 minutes.
Awesome. All right. Hello. Welcome back, everyone. All right. Let's continue where we left off. You should have now all of the files that you need to continue with the tutorial. So for me, this one, it took exactly as at home. I'm actually at the office right now where I work, at the campus where I work. It took 2 minutes and 26 seconds to get the 30 files, the 30 data sets that we are going to use for our session. If you had any issues downloading the data, please let me know in the chat, and I will try to address them immediately. All right, so the next thing we're gonna do is we're gonna create variables to the path where our data lives. So remember, we created a new folder or a new directory with the name of the country or the name of the city, underscore data, and then a new directory for with the raw data files. If you go in Jupyter Lab to your files, to the data folder, you will see Japan, and then you will see a raw underscore data. Of course, you're not going to have the CSV one because I've already run all of the code. That's the next one. That's the next step. So you should have at least the raw data file. That's awesome. It took 2 minutes, and Tetsu, it took 2 minutes and 53 seconds for you. Fantastic. Okay, so let's run. Remember our check or add function. We can actually see the doc string of this function. This function will help us check whether one or more directories exist. And if they don't exist, it will create, combine, and return the new directory. Okay, so let's create variables with the path to these directories. Let's count that we did get, indeed, 30 files, 10 for each country. Oops, and I have 20 because I duplicated the files. So I'm gonna have to deal with this here in just a second. Yes, I already had the file, so that's why I have 20, but you should have 30. Okay, perfect. So now let's talk about data frames, because we're gonna be evaluating data that is gonna be contained in a data frame. When we switch to Dask, Dask is also going to be managing many of these data sets. So it's very important that we understand the concept behind a data set. The first thing we're going to look at, if you have dealt or if you have used Python dictionaries are also called, you know that they are also called hash tables, which is a data structure that has a key and a value pair. A key should be unique or should be a specific number. And then the values, it could be many, many, many numbers. It could even be another hash table or another dictionary. Pandas data frames can be created from dictionaries, and the key will become a column. Think about this as Excel spreadsheet, where you have the columns at the top and then the rows on the left. So the name of the key of your dictionary is going to be the column, and then the values. Here I'm using the function range to create 5 numbers from 0 up to but not including 5, from 5 and up to but not including 10, and from 15 up to 20, but up to but not including 20. So let's evaluate our toy data frame. So as you can see here, the keys have become the columns of our data frame. The index is on the left, and now we have the numerical values representing the ranges that we passed in our data structure. We can access the columns in the same way in which we access keys from a Python dictionary. Here I have column A, I pass it into brackets, I put it inside brackets, and then at the very beginning I have the name of the variable that contains my data. The next thing we do is that we learn about masking with and conditions, passing conditions to Panda series earlier in the tutorial. But now we're going to do so. We can also do so with Pandas data frames. But the only difference is that we have to specify, if we want to, we have to specify by which column are we actually filtering by, or are we creating a condition for? And in this case, I am selecting column A, all of the elements, filter the data set by all of the elements that are greater than 2, that have an element, a value greater than 2. Notice how now we only have the elements, the rows are index 3 and index 4. As you can see here, 3 and 4. Now, pandas data frames have very useful methods to allow us to get descriptive statistics from the dataset. We can use the describe method on the toy dataset to get the mean, the count, the mean, the standard deviation, the minimum value. So your regular descriptive statistic, 25%, 50th percentile, which is also the median, the 75th percentile, and then the maximum value. We can also call particular methods or specific methods to the data frame, and what we will get in return is a panda series. The panda series will contain the name of the columns in the index and the values that we computed, in this case, the mean. It will contain them as the values of the series. As you can see here, in my index, I have column A, column B, column C, and then I have the mean of this column, the mean of this column, and the mean of this column. Now, you can also think of a pandas data frame as a combination of panda series. Here I have, think of column A as a series, column B as a series, column C as a series. We combine them all together, and now we have a pandas data frame. So now, let's evaluate the files that we just got. First, we're gonna pick a random number. We're gonna pick 5. And then that file number, we're putting it here so that we can iterate over it fast and as many times as we want. And then we're gonna say, for my country, which I believe my country is Japan in this case, let's add a new cell here. Yes, so for Japan, I want you to pick the file number 5 that ends with .csv.gset. Remember, the f string is a method that was put into Python 3.5 and above, I believe, either 3.5 or 3.6 and above. And the f string allows us to pass arguments inside brackets, inside strings. So a string that contains evaluations or variables or anything in it by only putting them in the brackets. And it's very, very useful. So pandas read CSV, the function that we're going to use. I believe that to this date is one of the functions with the most amount of parameters in pandas. I could be completely wrong about this, but it has, I believe, over 50 parameters that you can specify. One of those, which my understanding is now is infer and is compression, but we will use it, we will make it explicit in this code, is compression. Compression takes in a specific type of compression for a file that contains what we are trying to read, in this case, a comma separated value that we just downloaded from the internet. We're gonna use low memory false. And the reason why we're gonna use low memory false is because data over, I wouldn't be able to tell you the exact cutoff number, but when we have large data frames that do fit into memory and they contain different data types inside a panda series or inside a column, then pandas will raise an error. And if you put low memory false, it understands that a column with many numbers or a column with a big length of values, with a lot of values, is going to have mixed data types. Remember that not a number or NaN values, missing values, is represented as a float. So if we have a float and at the same time we also have a string in that column, we're going to have mixed data types in an array that should only have a specific data type. We're passing the encoding just in case we hit something that we don't want. And wow, the thunderstorm here. And then the next thing is that we're going to use the info method from pandas. The info method gives us a few things. One of those is how many variables do we have in the data set, or how many columns do we have in the data set? How many rows do we have in the data set? What are the types, the data types of these values? And the parameter that we're passing, or the argument that we're passing to this method, is called memory usage. We want to know how much does the decompressed value how much memory does this decompressed file takes in our system. And by passing the memory usage equals to D, pandas will return just that to us. If the file is very big, this could take quite a while, but because they are not as large, it only took about a second. And so this particular file is occupying about 160 megabytes of memory RAM in my computer. We can use the same methods that we use in the lists, and we can use the head to evaluate the first 5 rows of our data set. Now, notice all of the cool things that we have here. We have a ton of things that we can explore. And so, for example, we have the name of the listing. We have the summary of the listing, the space. We have experience offer. I have one of my good friends. He is a host in Airbnb. And he was telling me all about the things that people offer in Airbnb. He actually helped me with a lot of the domain knowledge that you should know if you're a host, but that you wouldn't specifically know if you are not, if you have never worked with this kind of data, or if you have never been a host before. For example, not every host charges a cleaning fee, but a lot of hosts do. We also have the host name, the host, from how long they have been a host, the location, so Shibuya, Tokyo, Japan, Tokyo. Some of them are more specific than others, and I believe this is very good. This is for privacy, to preserve more privacy. They don't give you the specific address unless you do the booking. That's my understanding of it, but I could be completely wrong about this. So it also tells you an about section of the host, so you can learn a little bit more about the host that you want to stay at, where you want to stay at. You have a picture URL, and we will be looking at pictures of the places that we want to see. It tells you the neighborhood, the amount of listings that a host has. So a lot of hosts, they don't just have one place. A lot of hosts do, but then others don't. Others might have multiple places rented out through Airbnb. We have whether they have a profile picture, whether the identity has been verified. I mentioned earlier that we have the price, and we also have the cleaning fee. We have weekly price, monthly price, security deposit, whether they charge you one or not, and if so, how much. Of course, this seems like a very high value, especially for us to see Australian dollars, but this is because this is actually in Japanese yen. We also have a cleaning fee, guest included. If you have extra people, how much will the guest charge you for an extra person? So that is actually up to the host to charge you more for an extra person or not. We have the time from the first review and to the last review, and then their ratings, which is very, very cool. Okay, so cancellation policy. This is quite interesting one. I spoke with a few people while I was working on this tutorial. I spoke with a few people that are hosts, including my friend and another person that is an acquaintance. And what happens is, with the strict cancellation policy, when you have a flexible, a lot of hosts often see people canceling on the last minute. And if you had people interested, but the weekend came on, you might have lost the opportunity to get somebody else. And then because this person canceled on a very short time notice, then you end up not making any money over that week. So we have a lot of information, and you probably noticed quite a few things that need to be cleaned, quite a few things that need to be fixed. And we're going to do that throughout our session. All right. You probably can hear the rain in my background. It's raining very bad here in Sydney. All right, so the first thing we're going to do, we're going to use the globe method to go recursively, or to go through each one of the folders for which we downloaded data and grab every single one of the files that we're going to be using. Now, I need to do some pruning here of my files because, and I could have done this with a quick terminal command, but oh well. I got to delete these ones because I downloaded them twice. That should be fine. So what we're going to do now, we're going to go through each one of the folders. We're going to grab each one of the raw files, and we're going to create a function to go over all of these files, decompress them, and give us a CSV file. Now, because pandas and Dask, they both have a compression parameter, we technically don't need to get them out of the out of the zip file, but we're going to do so to show you how you would deal with this if you were to encounter very messy data that even if you were trying to decompress it and things happen, or you were trying to just work with them from the compressed file and you will need to decompress it, how will you do so? So that's why I want to show you that. But both options, Dask and Pandas, allow you to read compressed files to this day. Okay, Japan is clean. Belgium, clean. Cape Town, clean. Okay, let's do it. So the first thing we're going to do is, before we do so, we don't want to go over every single one of the files one by one. We don't want to go over every single one of them one by one. And we also don't want to specifically loop through them because that would take quite a while. That would be a very lengthy computation. So what we're going to do is we're going to use one of the Dask APIs. We're going to use the delay method to delay reading all of these files and writing them back into CSV files. How are we going to do that? Well, first, let's use our globe function that goes over. It uses pattern matching. Here, the star signifies everything that ends with underscore data, grab it. And then the OS path join is going to combine our data folder with whatever stars ends with underscore data, has a folder that is called raw data, and then ends in .csv.gz. We're going to run this. And now you can see that we have all of our files, all of the Japan files. And if you want to check the end, oops, you can also use a negative indexing, and you can look at the last few. So here's my Belgian one. We just saw the Japan one. Now we're going to create a function, takes in the data as a string, or the location of the data, takes in a path out where we want to write these decompressed files to or at. It takes a new directory. What are we going to name this new directory as? It takes the country of the city, the names of the variables that we created before we downloaded the data, and then it takes the nums, whatever number we're going to give to this new decompressed file. That is part of the loop. That is not part of the function. Then what we do is we read the CSV file as we did above with Japan. We write it to CSV in the new path, in the new folder that we want. We tell Pandas that we don't want it to add the index as a new column to our data frame. And then we continue using the encoding just in case. All right, so we're going to run this function. Now we're going to talk about the Dask delay API. So Dask delay, it allows you to make a lazy computation or a function. It allows you to make it lazy, and it also helps you parallelize that function for you. And I feel like the best way to describe it is actually to show you what is happening. So I created a little implementation here, inspired from the Dask tutorial from SciPy 2020, but with a different flavor. This one is called PEMDAS. If you remember from high school, the PEMDAS set of instructions on how to think about arithmetic operations. You start with the parentheses, you go with the exponents, then you multiply, then you divide, then you add, then you subtract, and you start from left to right. At least, that's the way I was taught, and I thought it was funny to bring it up. So that's exactly what our computation is going to do. It's going to start with the actually, it's not going to start with the parentheses because we don't have a need for the parentheses, but it's going to start with the exponents. Now, the next thing we're going to do, we're going to make each one of these functions sleep for about a second, and then we're going to run it and see what it does. So the first thing we're going to do is we're going to import the delay and the delay function from Dask and the sleep function from time. We're going to create our toy data frame with fake data. So here's a little toy data frame. The next thing we do is we create an exponent function. It takes in a value and then it raises to the power of 2. Now, what happens is that when we add an array to a function, arrays in NumPy and arrays in or Panda series, in pandas, they do what is called broadcasting. So when you try to apply an operation to an array, you're going to apply it to the entire array. So the a to the power of 2 is going to be 1 to the power of 2, 2 to the power of 2, 3 to the power of 2, 4 to the power of 2 in column A. The same is going to happen with multiplication. We're going to multiply all 3 arrays. We're going to divide all 3 arrays. Here I have the little parentheses that I was missing at the very beginning. We're going to sleep for a second in each one of these functions, and we're going to add all of these 3 together. Then we're going to subtract them together, and we are going to sleep for a second in all of those. And I know that seems a little bit convoluted, so just bear with me for 1 second until we get to the visualization so that you can understand, so that you can visually see what Dask is trying to do in parallel. When you delay a computation, you're essentially trying to say, okay, how many cores do we have in this computer? Can we take advantage of all of those and send the instructions to this cores and to these cores, and then try to put the computation in parallel? So let's see how that happens. I'm going to run the functions here. Let's examine our array again. So remember, we can access a Panda series from inside a data frame with the same construction as with a Python dictionary. Brackets, name of the key. In this case, brackets, name of the column. Now, we are creating 3 variables, exponent 1, exponent 2, exponent 0, exponent 1, exponent 2, where we pass in every single one of the columns in our data frame. Then we multiply all of these 3 columns with our function multiply. We divide all of these 3 columns with our function divide. We add all of these 3 columns with our function addition. And at the very end, multiplication, division, and addition, we subtract them all from our with our subtraction function. Let's see how long that takes. The time when you see an element at the top of your cell that has 2 percentage signs, that is called a magic function. A magic function adds functionalities, really nice functionalities or specific functionalities inside a cell. This one in particular allows us to time how long it takes to run a computation inside a cell. I'm going to run this function. If everything goes right, it should take about 7 seconds because we did 7 implementations of the functions that we have. And here we can see that the function took 7 seconds to compute all of our computations. Now, when we want to use Dask delay to parallelize a function using the cores that we have in our computer, we can wrap that function that we have around the delay function. Another way of doing this is that we could have, I'm going to add a new cell at the top. We could have a define, I can just type, define some func. We could have any kind of function. And if we don't want to wrap it, if we want to make it a delay function from the very beginning, what we can do in the instance is to add a decorator at the top of the function. We could say Dask delay, or we could go straight with the delay function as well. So this is another way of doing the exact same delay function call and then your array. All right, so let's run this one with the same way we did the previous one, except that now every single one of the functions has been delayed. Now notice that this took 7 microseconds because no computation has taken place yet. This one took 7 seconds. This one hasn't even happened yet because Dask has created delayed objects that are lazily evaluated until we call compute on them. Compute is the method that allows you to bring back the result of a function once you delay it. Notice if I call result, my result is a delay function pointing to the last bit that we call, which is subtraction. Subtraction contains all of the first 6 operations that we did. So now we can call compute. The first time it took 7 seconds. And then now this time it took 3.11 seconds. The exact same computation. We still, every single function still slept for a second But because they happen in different cores of our computer in parallel, then it took less amount of time to compute. Now, it is a little, it's not as easy to wrap our heads around what is happening. And Dask has this really, really useful method called visualize that it creates a directed cyclic graph, which tells us where the computation started, what happened in between, and what was the end result of this computation. For that, we can call the visualize method. And here is what our function did. Let me zoom out a bit so that everybody can see. Okay, so let's talk about what happened. How did this get parallel? So we created the exponent functions. We raised to the power of 2 every single element in each one of the 3 arrays in our toy data frame. Then we had a result. Each one of those results went into the addition, the multiplication, and the division function. Once we had all these 3, we had an element for all these 3. This 3 got passed into the subtraction. And the subtraction function gave us only one array of all of these computations subtracted or computed in sequence, and all the way giving us a subtracted array. And this is the array we got back. So, all right, so that is the that's delay. You can create any kind of function you like, delay it with the decorate, and then compute it. If it is a function that takes a lot of time, you will see the significant speed up by Dask parallelizing it. But if it's not a function that really does that is able to parallelize something, that it's not easily breakable into different pieces, then using Dask might not really give you any benefit. All right, so here's your second exercise for today. Create a pandas data frame with toy data. You can even use the same one that we created a second ago. Create 2 functions that perform a computation on a different pandas series of your data frame each. Make your functions so that they sleep for 1 second. Create 1 function that takes the output of the previous 2. So you're going to create 3 functions. You're going to have them sleep for 1 second. You're going to create 1 function that takes as input the output of these 2. You're going to make it sleep for 1 second as well. You're going to evaluate the implementations of your functions without Dask delay. And then you're going to evaluate them using Dask delay. Compare both functions. So here you should write your 3 functions in this cell. Here you should write the first implementation and run it. Here you should write your delay implementations of those functions. And here you should test the delay function. So I'm going to give you 7 minutes again. And starting now. I agree, Ted. So broadcasting is super, super useful. And actually, we will be using that quite a bit later on. If you finish, let me know in the chat, and then we'll move along to the next one. To get the data as CSV files. How is everyone doing with the formula, with the functions? All right. So, has everyone been able to finish the functions? Still thinking. No problem. All right, perfect. That was quite loud. Sorry about that. All right, so let's continue and let's move on and let's get the data. All right, so the next thing we're gonna do, we're gonna use this function that we created, the get underscore CSV underscore files. We're gonna apply it to every single one of the data files that we have. We're gonna send it to the path out to the data file. We're gonna create a new folder called CSV files, and then we're gonna apply. We're gonna give it the name of my country. The nums here, for which the function we defined had a parameter, was so that we can enumerate each one of the files and then give a unique number to each one of these files. Now we're going to group all of these functions in a results list, and then we are going to compute each one of the results in a list comprehension. So before I do so, so that I don't get the same result from before, let me delete my CSV file. And okay, perfect. So let's go ahead and run this file, this loop. And notice that, remember, because that's create delay objects, nothing has run yet. So that took 68 microseconds. So if we examine the results from our list, every single element contained in our list is a delay object. So how do we call the delay objects, or how do we run them? Well, we have to call compute in each one of them. And we can do so by using the results that compute, or in a loop. This will be for result in results, and then we will call result that compute. In this case, we're going to do it inside a list comprehension, and then that list is going to have the printed value done with file number X. So we're going to run this one and get our CSV files. This one should take about a minute and a half to finish reading, decompressing. As you can see, that CSV files to my left just appear again, and now all of my files from Japan are being read and decompressed by Pandas. So it says done reading and saving file 0 and so forth. But it's also doing it not just for this one file, but also from for all of the other files in our results list. Let's check and see. All right, so this should take a couple of minutes, or maybe about a minute and a half. Let's see. So we do, while that runs, if anybody has any issues running this cell, please let me know. And also, while that runs, what we are going to do is we are going to go on our schedule short break that is supposed to be at 11:45. It's 11:40. So let's do that right now while we finish decompressing all of the files. We're gonna take the short break. So be back here in 5 minutes at 11:45 Japan time. Okay. Okay, perfect. So let's continue. We have our data already decompressed and as nice CSV files that took quite a long time, probably because all of the things running in my computer at the moment. So let's check out how many files we got. We got 30 files, 30 decompressed files. So that's great. We iterated over our data folder, every country folder that ends in underscore data, the CSV files folder, and then every single CSV file. So that's great. Let's go ahead and go and clean and reshape our data. So in this notebook, we talk about how to think about the data analytics cycle, how to form a project or idea or a task, how to find the data we need and work around some of the inconsistencies that we might find, how to make directories and folders work for us, how to manipulate one-dimensional arrays using Pandas series and two-dimensional data structures using Pandas data frames, and how to delay and lazily compute operations using that. Let's move on to the next one. Now, the next thing I would like you to do is go to the kernel sessions that you have on right now and shut down kernel or session 00, stage and data. So shut that one down, close out of it, and open up 01. So go to the notebooks, and in the notebooks, click on 01, clean it. What I'm going to do with the challenges is that I'm going to combine both of those towards the end of this session, and then we'll just have a big challenge at the end. We still have exercises in this notebook, but we'll combine the challenges for the very end. Okay, perfect. I have a nice quote that I found from Napoleon Bonaparte, and I switched it up because I thought it was really cool, but it didn't say exactly what I wanted. And it is that there are only two forces in the world, dirty data and clean data. In the long run, the dirty data will not always be conquered by the clean data. So I even changed Napoleon's name on that one, but I hope you find it as amusing as I did. So now we're on step 3. Now we have a lot of data. And of course, my hope is that you come back to this notebook later on and then you do your own work on Airbnb data if that's something that interests you, if you're thinking about a vacation, and that's one of the places that you will want to use for your stay, do whatever you go. So in this lesson, we're going to talk a little bit about structured and unstructured data. We're going to jump into data cleaning. We're going to talk about what is data cleaning. Then we're going to talk about data frames, and then we're going to go into cleaning data, clean the messiness that we have in this data sets. So structured data, what you can find in databases, they're neatly organized in relational databases or in spreadsheets where you have columns and rows, and the columns represent a feature of an element inside a row. So that's what we think of when we think of structured data. Now, structured data, on the other hand, is what we see when we get emails. But the data that we catch in the wild, for example, emails, textual data, menus, documents, any documents, pictures, all of that is considered unstructured data, and that sometimes take a bit more work to get to format it into a more into a nicer format or into a more usable way. So most of the times we want to deal, especially when we're doing data analytics and data analytics at scale, we want to deal with data that is neatly organized or in a tabular format. There's a really good paper by Hadley Wickham called Tidy Data, where he explains what the structure, or he formalizes what the structure of tidy data should look like. And it's very nice. I have a reference here for it, so you should definitely check it out. Okay, so let's talk about data cleaning. Wikipedia has the most beautiful definition of data cleaning, which in turn was taken from a paper from Xiaoming Wu in a review on course warranty data and analysis. It says data cleansing or data cleaning is the process of detecting and correcting or removing corrupt or inaccurate records from a record set, table, or database, and refers to identifying incomplete, incorrect, inaccurate, or irrelevant parts of the data and then replacing them, modifying, or deleting the dirty or data. I think that summarizes exactly what we're going to do today very well. But I still want to go over the non-exhaustive checklist of things that we need to think about when we first get a data set and we know it's messy or we know there are a lot of inconsistencies in it. So we want to make sure we go.
I'm sorry, Ramon. Your voice is really choppy.
Your voice is really choppy.
Maybe turn off your video
Maybe
and
turn
try
off
it again.
Okay, can you hear me?
Yes, now it's better.
Okay, but it's still a little bit, is it still a little bit flaky?
It sounds much better now, actually. Go ahead, sorry.
It sounds much better now, actually. Go ahead, sorry.
Okay, no problem. Thank you for letting me know. Okay, so let's continue. Actually, I know what I'll do. Can you hear me fine?
It sounds stalicky.
It sounds bad.
Okay, can you hear me fine? Are you able to hear me? Okay, much better now. Okay, I just did something to try to make it better. Sorry if that disappeared, if my screen disappeared for a second. Can you hear me much better now? Okay, perfect, much better. Awesome. All right, so let's talk about the checklist before we go into data cleaning. Oops. So, do we have column names? Are the column names normalized? Do we have lowercase, spaces, no spaces, numbers, numbers only, names? What do we have to represent the characteristics of our data? Do we have dates? If so, how are these represented? Sometimes we might have different dates representing in different ways, and that could be very cumbersome to deal with, or it could be quite easy, quite straightforward. But these are questions that we need to ask ourselves. Another one is, are there different data structures within an element of an observation? For example, do we have in what should be a single cell, do we have a list of values in a single cell? For example, if you recall, when we glanced quite quickly over the data frame that we read from Japan, we have one of the columns that had the amenities that a listing contains, meaning TV, internet, radio, and whatever. So that was contained actually in a list, and that list will be inside was inside a single element of Panda series. So that is quite tricky to deal with, and we should know how to do so, or we should be aware of how to clean that. Now, do we have numerical data points representing monetary value, which we have in this data set? We have denominations, and Python will interpret anything with a sign, with a dollar sign or a yen sign or a euro sign. It would interpret it as a string because it doesn't understand what what a currency value is. Do we have missing values? This is extremely important. Are we missing? Are they missing at random? Are they missing by accident? Are they intentionally empty? think about a survey. When you're supposed to take if-else statement question, for example, do you like movies? If yes, ask them which kind. If no, continue on to the next section. That will be, if you continue on to the next section, that will be an empty element. And the reason being, not because it was wrong, but just because you didn't like the previous question, what was asked of you in the previous question. So, do you have any outliers? Are there any duplicate observations in the samples in your data set? So all of these are very important questions that we should ask ourselves when we get data. What do we have? How is it represented? How can we make it even better? All right, so now that we know about data frames, not data frames, now that we know about data cleaning, what it is, the kinds of data that we can take or that we can have, structure or unstructured, let's talk about what is a Dask data frame. In essence, a Dask data frame is a lot of lazy pandas data frames. So if you recall, the delay function didn't get evaluated until we call compute on it. The pandas data frames have a similar representation or interpretation or way of using them. And that is, we can call compute on different computations. We can call the head method, and that will execute a computation. We can call that tail method, which does the exact same thing as that head, but it gives us the end of the data frame. And the next thing that we can use to call a computation from Dask as well is to call the len element, or LEN, to get the shape of the rows, or how many rows do we have in this data set. So the first thing we're going to do is we're going to import the following libraries. Now that we have the following libraries, by the way, was everyone able to run this cell successfully? Was there any issues here whatsoever? Oh no. Can everybody hear me? Can everybody see my screen?
We can hear you great, but we don't see your screen is white.
How about now? Can you see my screen?
No.
Okay. So let me do one more thing. And I'm very sorry about that, everyone. Let's
No
do
worries.
thing. So my screen is gonna go black for a second. And my screen sharing stopped. I'm gonna go down to, I had 3 screens, and I'm gonna go down to 1.
I see.
So,
Okay.
so to see if that increases, if that takes less resources from my computer.
Okay.
All right. So I believe I'm sharing my screen now. Can everyone see it?
The screen is back on now, yes.
Okay, perfect. So now I'm only on 1. So hopefully this is much better. I don't see the chat immediately. So Wanda, will you please let me know if I have any questions or anything?
Will do.
Okay.
Great.
Awesome. So if anyone had any issues with this cell, if everything went through fine, all right, let's continue on. We're gonna create a path again to our data folder. We are going to check the Belgium data folder. So now let's talk about how Dask data frames read data into the session. So the way Dask data frames read data is that if you remember the glob method from earlier, where we used it to grab all of the files given a specific condition or a string pattern, we can do the exact same globing functionality inside a Dask data frame. And what it does is that we can add the star at the very end or in between the elements that we are trying to catch. And Dask will do just as glob and grab all of the files that have the start with Belgium, have any number in between the underscore after Belgium and the .csv. And it will return them and it will read them into memory. Not into memory, sorry. It will try to read a little bit of them. So let's explain what is happening here. As you can see, we have quite a few things going on here. we have the data frame in front of us. We have all of the columns, but we also have partitions because we have 10 files. So because we have 10 files, we have 10 tasks. DAS has not read anything, but it read just a little bit, just enough to infer the data type of each one of the columns. So it's saying this ID must be an integer 64. This listing URL, it must be an object or a string. The scrape ID, it must be an integer, and so forth. So because, so here's the way how DAS works. So it creates different partitions. The default option is 64 megabytes. And remember that our Belgium data is actually quite small. It's about 50 megabytes each one of the partitions. So it didn't even have to repartition them. So if they would have been greater than 64 megabytes, say double the size, we would have seen, for the same amount of files, maybe we would have seen 20 partitions. Then it reads a small fraction of the data, infers the data type of each column, and it starts creating a directed acyclic graph, which is a set of instructions from one point to another point, not going back to the previous point. If you recall, that is a directed acyclic graph is what we created in our previous implementation of the delay function of task. And here is the picture for that. All right, so let's continue. I have a formal definition here for those of you who are interested. It's a very cool concept, the DAGs, and after you read the definition, after you like understand what a DAG is, you will start seeing them everywhere. Okay, so now let's go ahead and check the columns that we have, the column names. So this return an index element, and then this index shrink the amount of names for columns that it was meant to show. And that's okay. We don't need them right now. We just wanted to check that we can access them, and we wanted to see the length of the columns. We're going to call the head method on the data frame, and let's see what happens. Right now, you should get an error, and that is intended. I wanted you to get an error because I want to discuss what happens. What are some of the key features that we should keep in mind when we use DAS for data frames? So this error was intentional. So let's go and examine. One of the things is because, if you recall, I mentioned a second ago that DAS infers the data type of a column by taking a small sample of it. One of the parameters of the read_CSV method that we just used a second ago is data types. And another one of the parameters is sample. Sample takes either two kinds of numbers. In a string, it takes an amount of megabytes or bytes, and as a number, it takes an amount of bytes as well. So you can specify, okay, how large do I want DAS? How large a sample do I want DAS to use when it reads the data? So I'm going to come back here to our DD for DAS. So we imported, I should have mentioned this, we imported from DAS data frame, our data frame as DD, in the same fashion as we import pandas as PD. In the DD.read CSV_CSV call, we can see here that it has a block size. The default is 64 megabytes. The sample is 256,000 bytes, which I am not 100% sure what this means in megabytes. Maybe it is 25 megabytes or so. I'm not 100% sure. So now we identify an issue. It says, I was expecting an integer, but I found a float. And that is because we're dealing with a lot of files. And because we're dealing with a lot of files, there are going to be a lot of missing values. And we need to deal with them correctly. So what we're going to do in these instances, we're going to go back to pandas for this second, although we don't have to. We could switch here, PD for DD, and do the exact same implementation by getting rid of the low memory false. But we're going to use it with Panda to get more experience with the delay function. And what we're going to do is we're not going to read any data in. All we want is to grab the columns. I'm going to run this function. We want to grab the columns in all of our files. So we're going to globe through them again. We want to grab all of the columns. We want to count them. And we want to filter the columns that are not unique for all of our 30 files. And this is going to make more sense here in just 1 second. So let's check out how many files we have. We should have 30. Yes, we do have 30 CSV files. So now what we're going to do is we created a function up here. This function reads in, doesn't read the data, only reads in the only takes in the columns of that data. And with low memory, with a parameter low memory false, and we pass it down to a list. So we create a list of columns for all 30 files, and we return this data frame columns list element. So we are going to delay this function with dash delay. We're going to wrap our function around dash delay, and we're going to tell it, grab the columns of every single file we downloaded in the previous implementation of our function. So we're going to run this one. Remember, I left the time here so that you can see that no computation has taken place yet. All of our computations right now, or all of our all of our elements inside the list are delay objects. All right. So the next thing is we're going to use the same implementation as before. We're going to call results, result.compute. And then we're also going to check the length of all of the files. So this should take, the last time I ran this, it took me about 25 seconds. But I said something similar in the previous one. It took about 5 minutes. So we'll see. Now, some of the computations here, they might take a couple of minutes. Some of them at the most, maybe 2 minutes. And the reason why, so this one took 24 seconds. And the reason why I still left them in is because I want to be able to show you what happens when you do something with Dask and you're doing it in parallel. What are the limitations? What are some key features? And how can you take advantage of all of these features? Okay, so the first thing is we read a list, or we created a list with all of the columns inside every single one of the 30 files. Now we're going to filter through. Imagine if we would have to go through all of these 30 files one by one, or in a continuous loop, and have to read in one, get the columns, take it out, save it, and so forth. So we saved quite a lot of time just by doing that. And then I put a funny meme here. I do have an exercise here, but I feel like we're running out of time, and I really want to, so I'm going to leave the exercise with you. I really want to walk through the following implementations of Dask. So I'm going to jump ahead in this section, and then we're going to merge all of the exercises with the challenges at the end.
We have a quick question in the chat box. Could we read in a limited number of rows when getting the columns, or does that risk getting the wrong column types?
If it's with that, okay, so let me tackle this in 2 ways. One, if it is with Dask, yes, you can read a limited amount of columns by specifying the block size, I believe, allows you to specify not just the size, but I believe the amount of columns. So let's see here. So strings, integers, none. Okay, can be a number like 64,000 or 64 megs. If none, a single block. Yes. So the way we're actually about to read it, so that's a great question, actually. The way we're about to read it is by specifying none to the block size, which means that it's going to infer all of them. Now, if we want to tackle your question specifically, if you want to read in just a few lines, you could say if your file has 100 megabytes, is 100 megabytes in size, you could say the sample number of bytes to use when determining the data type. You could put it so that, I don't know, 1 megabyte, maybe it will be 2 of the rows. So you're kind of playing with the size, not with the specific columns. In Pandas, though, you do have a method called skip row or end rows. And let me show you what that looks like. So in Pandas that reads CSV, you can do exactly what you just suggested. And skip rows, nope, end rows. So if we use end rows, we can say just read 1 row. So actually, I didn't try. This is a great question. I didn't really try if I put end rows because I'm not really reading the data set. I'm accessing the columns only. So I thought I was already doing the end rows, but that's a very interesting observation. Maybe we'll go even faster. It took 24 seconds here. Maybe it would go even faster if I just put end row 1, which will be the actual names of the columns. So that's a very good observation. All right, so we're going to use the function reduce And what we're going to use, so reduce takes a function as its first parameter. The second parameter is an iterable. It could be a list. It could be a pandas data frame. It could be a set. It could be anything you want. And it starts from the function, takes the iterable, and goes through it and reduces it to a specific number. Let's see what's going to happen here. In our instance, in our case, we're going to take two things. We're going to take two lists. And then we're going to take one. We're going to turn it into a set. The set methods in Python have very useful functions, very useful methods. One of those is intersection. And the reason why we want to get the intersection is because we want to get all of the columns that are in common with any given data frame, with any given other data frame. So we're going to convert those into sets so that we can take the intersection of the two, and we're going to reduce those 30 lists of numbers into a single list of columns that we're going to use to read in our files. So I'm going to run this. I'm going to run this function. Then we're going to call reduce is lazy by default. If you remember delay is lazy as well. So delay until we call compute, or until we wrap a functionality that makes Python or that makes DAS call compute on it, it will not do anything for us. The same happens with reduce. So if we wrap the reduce function around a list in Python, what we will get back is a list. So, okay, so here we're calling reduce. We're saying, I want you to apply this function to all of the results, to all of the files, to every single one of the elements, every single one of the lists of columns inside my results variable. Filter out, if there are any nones, filter them out. So that's what's going to reduce all of our lists of columns to a single one. So let's do that. Let's check what we have. Okay, so we are printing the first 5. Let's check the length. Let's see how many columns in common do we have between all of our 30 data sets. So we have 106. That's great. Now, we've been using list comprehensions, but Python also has a very useful tool called dictionary comprehensions. We can say, for every single column inside our new list of columns that we just created, I want you to create a key value pair between the name of that column and a data type string. I want you to print it. So let me say that again. We have a column as the key and a string as the data type, as the value, which is a data type. And we're going to do this for every single column in our new list of 106 columns. Now we have every single one of the columns with a pair of a value of the data type that we want to read in the data with. And now we can finally read in our data and start cleaning. So here's what we're going to do. We're going to use dd.read_csv again. You can check what happens here, the path. The nice thing about Dask is that the path allows us to glob files in a directory or in a folder or in many folders. So here we are going through all of the countries folders, all of their CSV files, and all of the CSV single files, or all of the CSV folders and all of the CSV files. So we should have 30 partitions once we run this. There you go. And we can see that we have 30 partitions. Now we read in the data correctly, and now we can continue on with our cleaning. So now let the cleaning begin. Because I've zoomed in quite a lot, maybe, oh, shoot. There you go. Okay, perfect. So now there's a couple of key things that you should keep in mind with Dask. I know I mentioned them earlier, but I think they're very important. I'll mention them again. Compute will start doing a computation on a Dask anything. Head will also call a computation, and tail will also call a computation. So use them carefully. We will use them quite a bit, just because I want to show you what happens when you do X and what happens when you do Y while you're cleaning data at scale. But once you're doing this on your own, you probably don't want to print head, and you don't want to call compute on many things until you finish your directed acyclic graph. Okay, so I'm going to call head, and that actually ran very fast. I am going to use Shift-Tab inside the head just to show you that you can use the default value is 5 to show you the first 5 rows, but also the partition from which it takes these 5 rows is by default the number 1. So essentially, we are using head on the very first partition or in one of the data sets. And this one must be, and compute is true, this one must be Belgium. So let's check it out. We have a column called country. And here it is. So the first data set represents Belgium. All right, so let's continue. Now, if you want to check the shape of your data frame and you want to check the amount of columns, the shape has to be, represents a compute. As we have to call compute on the shape, otherwise it will be a lazy evaluation of the length of the data frame. We can also call wrap this around, wrap the data frame around len, and the shape would always return back the amount of columns, because that is an easy compute for Dask. Another thing that I would like to mention is that in pandas, we usually call the data frame df. In Dask, it's usually called ddf for Dask data frame. Now, remember that we're going to start creating. I am not going to run this cell just because it's going to take a little bit, but you can run it if you like. Now, a couple of things. We read in a lot of data that has been scraped periodically. That means that we should expect to have quite a few duplicates. People join Airbnb and people leave Airbnb all the time. So what we want to capture with all of the data is to see whether we can make sense of how the pricing has changed, how the listings, the way they are, the cleaning fees of the listings that we're interested in, or listings that are similar to the ones that we're interested in, have changed over time. So to do that, it's nice to still use host listings that might not be available right now, or host listings that are not in the latest scrape of Airbnb from inside Airbnb. So anyways, we want to get rid of duplicates. So we should expect to have a lot of duplicates, but the issue here is, and I'm going to run this cell, the issue here is that because every single data frame is right now is represented in isolation. So we have n partitions, we have 30 partitions, and every single data set of those is represented as its own entity. Even if I call and by the way, I haven't explained what is happening here, so sorry about that. Map partitions goes to every single one of these 30 partitions. What we can do in map partitions is apply a function to every single data frame. So map partition is taking X. X in this case is every single one of our 30 data frames. So every single one of our 30 data frames right now is that X in the lambda function. If you have seen if you have not seen lambda functions before in Python, this is an anonymous call to a, this is an anonymous function that doesn't need to be defined in the regular way. And we can assign it to variables and use it as such for very quickly iteration and so forth. The duplicated method is a pandas method, meaning we cannot apply it to a Dask data frame, the duplicated, but we can apply it to many or multiple pandas data frames. So that means that this X right here is checking for all of the duplicates in every single one of the pandas data frames. Now, it returns 0 because every scrape has been independently from one or the other. So how can we identify our duplicates in the data set? Because before we even get to cleaning, before we even get to dropping missing values or dealing with missing values, we might want to make sure we don't have duplicates and we don't end up dropping missing values because the amount of them were very large due to the duplicates in the data frame or in the data sets. So let's check whether the 2 unique identifiers that we have in our data set, and we can come up here to the df head method, we can check that we have an ID for a listing. So every row is a listing. And you can see here, it tells you listing URL, scrape ID, when was it last scraped, 2019, 10, 25, the name, and so forth. So you have a plethora of information. Now, we also have the host ID. So which one of these 2 actually represents what we are searching for? Let's find out. Let's check whether these 2 are unique. So for row 0, in the first data frame, The ID for every single row, for that matter, the ID and the host ID are never the same. Meaning we have to figure out a better way to drop duplicates or get rid of them, besides just saying, grab the host ID. If you see a duplicate, get rid of it. That shouldn't be our approach. So let's see whether the frequency of these two changes. If anyone has ever used group by before, group by is a very useful functionality to gather data given a condition or given an element, and then summarize another piece of information from our data frame. So the way I like to read group by is, in this data frame or these data frames, for each host ID and ID, I want you to grab the name column and count the elements for these two elements combined. And we are calling compute so that we can see the results. So we're going to run that. So what we're trying to assess is, okay, so now that I know that the host ID is not equal to the regular ID given to a host listing in this data frame, are the numbers, are the amount of times that they are represented in my data frame, are they the same or are they not? If not, what is the difference? So let's check it out. Disable scrolling for outputs. Okay, so this didn't print out very fine. Let me see if it's because I am very zoomed in. Let me zoom out a bit. Okay, there you go. That's why, because I was very zoomed in. It kind of like compress sort of the view of the file. I'm gonna zoom back up here in just a second. I wanna show you the difference. So I'm gonna enable scrolling. Okay, so notice the first host ID. It seems that the host ID might not, okay, we identify that it's not the same as the ID, so we cannot drop duplicates just on that. But how about this? This host right now has two IDs, and then these two IDs map not only to the amount of partitions, to the amount of files that we have for Belgium, but it also amounts to the amount of files they might have for a listing. So let's see whether host ID, actually whether a host ID, or sorry, a host has multiple listings, and then the ID column belongs to that listing that belongs to this host. So let's confirm that, because we don't just want to randomly drop duplicates from a data set and then figure out that we need them later on. So let's check out. We're going to use n partitions in our head code to see the first 10 rows that have a host ID. Notice what we did here. We picked this ID, 10026319. We are going to mask it. Remember our masking from the previous previous notebook. We're going to mask an array, and we're going to call the first 10 elements that appear given this ID in each one of the partitions. So notice what just happened here. So this is great. We have one ID in one partition, another ID in another partition. You can tell this is a specific partition because it was, here's the timestamp for the scrape. 2019, 10/25, 2020, 02/27, 2020, 02/27, and then it continues on different scrape timestamps. But the ID has not really changed. Let's explore this even further. So we grab all of the partitions we could. There's only 10 for Belgium, but we can tell we were only grabbing an element for Belgium. So essentially, we could just say the first 10 partitions and do that, and we will still get the same result. So now, what we are after is we're trying to remove duplicates. We identified the host ID refers to a unique identifier for a host, and the ID for a location, the ID for every single listing is actually per listing for a host. This will make more sense in the option one now. So we can use a combination of host ID and name. Let's show the name actually. And let's come here and see what is happening in our data set. Okay, so here's name. Perfect. So notice that we have an ID, 1006, 100693, 4260, 3965, clearly different. But then this one is again 4260, and this one is again 3965. So we have duplicates of these two. Now, Notice the name, historical city, Antwerp Center City. So it seems like this person has two listings, and this person has two listings at two different spots in the city of or in the historical city of Antwerp, and then Antwerp in the center of the city. So he has two listings in two different locations. Now we can really tell whether we have duplicates or not by doing a double masking. In this one, we're going to take that same ID. We're not only going to take that same ID, and we're going to tell Dask, give us this ID only across all partitions. But we're also going to say, give us the name that says historical city of Antwerp. Let's see if this is really a if we really have duplicates for this particular person and for anyone else for that matter. And the answer is yes. Now we're showing a name and last scrape. Notice how all of the last scrapes ID stamps or timestamps are different, but the name is the same for the same host. We're using the host ID. So we clearly have duplicates, and now we have a way to get rid of them. We can use the name column, and we can use the host ID column. Now, let's notice what's the difference between ID and host ID. Let's check it out. All right, same thing happens. Same thing happens. We're using a particular ID that belongs to the very first one that we noticed, and we filter out name and the last scrape date. We looked at the 10 observations that appear in 16 partitions. Of course, we only have 10 data points for a name and an ID of this kind, which belongs to a host in the country of Belgium. So we're not going to have 16 elements, but we will have 10 from the first 10 partitions. Notice how all of the scrape times are different. This is great because this is what we want to identify early on. This is what we want to get rid of. This is what we want to deal with in the best way possible. So now that we have what we need, let's identify the duplicates. Let's see what happens when we identify whether there are duplicates or not. Now remember, X in this instance is our data frame, is our pandas data frame. Now we are selecting, remember that to select a column from a pandas data frame, it is similar to selecting a key in a dictionary in Python. Now, when you want to select multiple columns, you can double the brackets and pass in a list of columns that you want. And here we are checking, okay, what are the duplicates? Okay, so notice that the very first time that we check for duplicates, we have 0. Now we're using X, host ID, and name. And now we really identify some duplicates in our data set. But we have about 400,000 rows. And I'm sorry, we didn't run the length because it is because it takes a while to compute, but I should have computed at the top. And we can do so here. So I'm going to add a new cell, and I'm going to call len in DDF to check how many rows we have. Then the next thing that you're going to notice is, okay, so what percentage, the next thing we would want to know, what percentage of duplicates does this mean in comparison to the whole data set? We're multiplying by 100 so that we can see it as a percentage and not just as not only as a blank number that doesn't mean much to us. So when we see proportions, sometimes it's better than not seeing proportions. So here we can see that we have 410,777 rows in our data frames, in all of them. And here it says that we only have 10,000 duplicates. That doesn't seem right. That's not even a 10% of the values. If you have never seen this implementation here, the underscore says in Jupyter Notebook, it says and actually in IPython, take the output of the last cell that was run and put it here. So now we can see that 10%, that 10,837 rows actually represents 2.63% of missing values, which is not right. That's just absolutely not right. So there is a better way for us to deal with missing values with and account for the overlapping duplicates in multiple partitions. How do we do this? Well, we can do this with the map overlap function that allows us to use the same implementation as map partitions goes explicitly to a specific partition, applies the function, returns the partition. Map overlap goes to a partition, allows us to specify before and after for a partition. So use this function in this partition, but also use it grabbing 2,000 rows, 1,000 rows, 3,000 rows from the partition above and the partition below. And we're going to see what that looks like. Let me give you an example here. We have here before and we have here after. We're saying, okay, take the average of my partitions, or the length of most of my partitions is about 1,500 rows. How about this? Take 2,000 from the partition above, take 2,000 from the partition below, check for duplicates between those two, between the combination of those two. Now, what are we doing here? Before we call map overlap, we are going to call map partitions, and we're going to get the length of every single individual partition. So notice the difference in sizes between all of our partitions. Let me...
I hate to interrupt, Ramon, but we're at time. Any last 20 seconds comments?
No, actually, that's completely fine. Yeah, so, well, no, I just want to encourage everyone to, let me actually take my screen out. So everyone, thank you so much for joining. I know we didn't get through as much as planned, but at least you get started with dealing with that, with messy data in Python and using Dask. You have a ton of data, you have a ton of exercises, and you have here 2 tools to help you do a very cool analysis for yourself. Pick a specific country that you'd like to go once COVID ends, and give it a go to doing some data analytics at scale in your own computer. And thank you so much for joining me. I'm sorry that we didn't get through as much with timing and all that, but please continue on your own and let me know your thoughts. My GitHub is there, you can reach me, and I believe my email is also available. So yeah, thank you so much for joining.
Thank you, Ramon, and thanks for everyone for attending, and also excellent work for our interpreters. Thank you so much. Take a break. We'll see you in an hour for our keynote. Thanks. Bye.
Awesome.